Hey, what's up everybody? So today I am gonna make a quick video just to explain some code I've written and talk a little bit about sandwich attacks on Polkadot. I just want to quickly shout out WAG Media and the HydraDX Council who put me onto this task. So without them, without their support, none of this would be possible. Um, so don't worry too much if you can't tell what's going on the screen at the moment. I'll explain everything. Um, and we can go through this in detail. I'll explain how to use the code, I'll explain what the code is doing, and I'll explain exactly what we're looking at. So super quickly, I'm going to explain all of this from the perspective of someone who can't code and someone who would like to use this software or would just like to learn more about how transactions work on substrate Polkadot chains and how sandwich attacks work in general. So let's start from the very start. What are we actually looking at on the screen? This is called VS Code. It's IDE. That essentially just means where you type the code in. You type the code in there and you can run it in there and you can see an output streaming out from the bottom. I'll explain that in a second. Then on the left, you can see this is Discord. This is the HydraDX Discord in the OmniWatch channel. The OmniWatch channel is essentially showing us all of the confirmed transactions that have taken place on the chain. You can look at this channel and think that you're the only person watching it, and it's very easy to think that it's just messages streaming out and nothing's happened. But in reality, there's a lot of people watching this Discord channel, and I see a lot of people talking about it. So I think this video will go great for those people specifically. Let's say hello to the people. Okay, we've said hello to the people. Great. So today's agenda, the code. What are we going to talk about? We're going to talk about sandwich attacks. One of the members of the HydraDX Council approached me about this task and basically asked me to write some code or kind of think a little bit about sandwich attacks, why they happen, is there any way to kind of avoid those attacks, or maybe just look a little bit further. So what I've done is I've wrote a script that will watch the HydraDX mempool and will notify us and save the transaction details if someone does a sandwich attack. How this works is we're basically streaming all the transactions from HydraDX mempool, organizing them in such a way, and then looking through each block and determining if someone is trying to take advantage of somebody else. As you can already see from the code that's streaming out or from the output that's streaming out, this is successfully showing us and organizing in a kind of nice little neat way all the transactions that are being submitted. So as you can see, just take a little example here. This wallet wanted to trade BNC into USDT, and then a short period later we see BNC into USDT. One thing you need to note is remember that the code is telling us the transactions they submit, not the transactions that get confirmed. So this guy submitted a transaction to sell a 714 BNC and get back out 294 USDT, but we can see that he got 297. So what this is the minimum amount out. That's when we're performing transactions in cryptocurrency. The transactions are called atomic. That means that if you don't get the minimum amount out, the whole transaction will fail. That's super useful for us. We won't talk too long about that today, but just bear that in mind. If you see the numbers don't really line up 100%, just understand that these are the transactions being submitted on the Discord as the transactions that are being confirmed. Okay, cool. I'll have a quick little run through the code and explain this for anybody who's non-technical. And I also will open source the code so you can run this code yourself. I will continue running it and storing up all the data, and hopefully down the road we can analyze the data a little bit and kind of determine who were the worst offenders of these sandwich attacks. But we'll see further down the road that we know who the worst one is already. Okay, so I'm going to explain this just from a super non-technical perspective. This is all written in JavaScript, and I'm running it with Bun.js. I'm using Bun over Node because Bun's just a little bit faster, and it's kind of the cool new JavaScript primitive. So this is also just importing everything. I wouldn't worry too much about this. It's just basically the pieces of code that our pieces of code use in layman's terms. It's basically just other tools that our code can use further down the code. Great. This, you can see us, is bringing in the kind of Polka.js API applications or whatever. Then we have this big array. An array is just a list of things where we determine all the different assets on HydraDX. We can, I did this manually. You can query this live, but it gets a bit messy with all the kind of new meme coins that are coming out and new everything. Thankfully, further down the code, I've got error handling. So if someone launches a new meme coin, the code won't just die overnight. But as you can see, these are all the kind of assets on HydraDX. Pretty cool. We even have some newer kind of more speculative assets. We can talk about that later. So this is our array. This next kind of section function essentially is a way to organize this array data, to pull all the data out of it as we need. This format function essentially, when we're reading the amount, so like you can see the amount here, it's given to us in this big long number, but we need to convert it into the decimal number. So we're using this format amount function to do that. Great, that's kind of the easier parts. Now we got the more difficult bit. Now we're in the main function. You can see that we're using the HydraDX kind of public endpoint. If you're intended on running this for a long time, and when I run this personally, I use the Dwellier endpoints. If you're going to use this a lot, you will need to approach an endpoint provider, or the public endpoints will just stop working or it'll just break or whatever. So I would recommend Dwellier. I think you can, if you tell them I sent you, I think you might get a discount code. So, you know, reach out to them for more information. So this is our main function. What this is doing is essentially just subscribing to the new blocks. So you can see that, like, this is the current mempool. The new block has come out. There's no transactions in this. Oh, but a new one's popped out. This wallet is submitting a utility batch all transaction. Great. So now we're also looking down through the pending extrinsics. We do need a way to kind of organize out the functions that are being called that we don't really need, or the methods. So you can see here that this wallet submitted the method of a utility batch all transaction, and that made multiple swaps, and you can see all the kind of swap details down here. I wanted to leave those in because those actually are pretty sexy details if you can look through them. There is a lot of value in kind of seeing the breakdown of the kind of details of his transaction. Great. But, you know, for this code, we don't really care about the kind of democracy stuff or the staking stuff. It's just from a trading perspective. This whole video is just like about trading, let's be honest. So here is the section we can basically tell the code to ignore certain methods. So like the X transfer tokens is basically bridging tokens. We don't really need to see that. You know, the democracy vote, we don't really need to see that. The unstaking, we don't really need to see that. If you say you want to use this code and you don't want to see whatever, let's say you don't want to see root or buy, you would just copy paste root or buy in there and it would start ignoring those transactions. Great. Down here, this is basically just reviewing the kind of tips. I'll talk about that in a little bit. This then is the kind of more sexy bit that is going to check if someone is committing a sandwich attack in the current block. How we're determining that is we're basically comparing the asset they're putting in and the asset they're putting out and seeing if they have two transactions in the same block. So how a sandwich attack works is a user will come along and will say, I want to buy 1 million stink tokens or whatever. Someone, just like we're watching now, like we can tell right now, we could see, like what we've just seen, we could see this guy wanted to buy asset 8.5 with USDT. We could see that before it came through on the Discord. And it's kind of part of the reason why I wanted to make this video is like I hear people talking about the Omnipool Watch Discord and kind of saying it's like the battleground. Whereas in reality, the Discord is the podium. It's like who has won. The battleground is the mempool, and I think sometimes people can't really see that, so they don't really know what's going on. They kind of just see the tape coming out, and they don't see the battle that happened to get to that tape. So I can't stress enough, like the true battleground of MEV is in the mempool, not in the list of confirmed transactions. There's a lot of value you can get from looking at confirmed transactions, but really it's the mempool that is where all the value is. So how sandwich attacks work, we see a target transaction just like this guy. We determine that we would be able to buy before him and then sell it back to him after. So someone comes along and wants to buy stink tokens. We see this pending. I think this is actually literally happening right now, where there's another meme coin. We see this user is putting in dot and wants to buy whatever this 8.5 asset is. So what we would do is we would jump in ahead of him, pay a higher tip, buy the asset ending in 8.5, wait for his transaction to get confirmed, and then sell it back to him. How we would do that, how we would order the transactions after, remember he needs to submit his transaction first, is we would change our tip on the first transaction. I will later in the video, we'll wait until a sandwich attack happens and I can show it all play out. I can show it play out for you guys, so you can kind of see it all happen in real time. Just to continue going through the rest of the code, there's not too much more. So this section is essentially looking through to see if someone has tried to do or has done a sandwich attack on someone else. It will print sandwich attack detected and the kind of transaction details of that attack. Then lastly, we will push all this information to a file. So attackers.txt. That's here. This is some of the previous sandwich attacks I've looked at. As you can see, there's a few of them. Why is that? Again, for the non-coders, all this information that you see isn't like saved. Like once we stop the code, we can't come back and look at all this. We could, but it'll go away pretty easily. Whereas if we can write all the information we need about these attacks to here, we can come back and review it and analyze that data later. So I guess now is a section where I should wait for a sandwich attack to happen and show you guys how it all plays out, and then we can talk about it in a little bit. Great. Okay, we're back. I actually didn't have to wait too long at all. Did not have to wait too long at all. But you can see that now we very pour one out for our latest victim. But here, this is the game we play. So I'll show you how it all worked now. So we can see a new block started. Okay, a new block started, this number of the block, and we see this wallet address. You can see it over here. It is the mouse. And the mouse, what the mouse did, the cunning Mr. Mouse, what he did was he noticed that this victim transaction, this guy, that this guy wanted to put in asset 8.5, let's call it, and take out dot. Okay, but one, let's notice a couple of things about this guy's transaction. One, he didn't tip at all. I don't think that really would have mattered in the grand scheme of things. We'll talk about that in a bit too. But two, he set his amount out. So what the attacker did, Mr. Mouse did, was Mr. Mouse determined that he was able to buy asset 8.5, yeah, before this transaction, while still allowing this transaction to get filled. So he was able to buy and still allow enough liquidity in the pool for this min amount out to still be met. After the min amount out, so after this transaction gets confirmed, you can see the mouse comes in again and takes the other side of it. This sandwich attack detected has been printed, so we know this is the attacker, Mr. Mouse, this is the victim, pour one out, and then the attacker is selling back again. Okay, that's pretty cool. Now we're going to go up to our, where is it gone? Our attackers list. Sorry, we're already on it. Our attackers list, and you can see, boom, here it is. the attacker, the mouse, the target here, and the mouse again. So the code works. We have um, successfully, shown a sandwich attack. We're kind of aware about it now. So next, I kind of maybe to go back to how this all started. One of the HydraDX council members kind of contacted me, and we were kind of talking about um, sandwich attacks, why they kind of matter, why they're good. Sorry, not why they're good, but kind of how they affect the community and kind of what to do about it. I've no horse in this race. I'm just going to try to do my best to lay out the facts, and the kind of the HydraDX community can kind of decide who wants what or who thinks whatever. Um, so from my perspective, I think that the best way to solve this problem is actually through a front end change. That it's generally probably best. Like, let's take this example here. If this user had just set a lower min amount out, um, the attacking transaction wouldn't have been able to go through. So if Mr. Mouse wasn't able to squeeze his transaction in before the victim, then he never would have been able to do a sandwich attack. So kind of what I think my solution to this is, I think maybe a slight change to the front end, or maybe when someone is trading in these meme coin pools, that they're kind of told, you're at risk of submitting a sandwich attack here. There is a kind of open debate in the kind of crypto world. You may have heard code is law. And that basically means that sandwich attacks are perfectly legitimate because it's based on the code, and I don't know, that people should be allowed to take advantage because they're of other people just because they're using the protocols exactly as designed. There's kind of this other school of thinking that is, we need to protect our users, or at least the users should know what they're getting into, or know that they're at risk of kind of getting preyed upon here. Where do I stand on that? I don't really know. I think it is what it is. If people are going to submit these kind of stinky transactions, or these kind of lousy, poorly thought out transactions, they are going to be preyed upon. And is the protocol at fault for that? I don't think so. But I guess that's up for more the community to decide. And I guess the last thing we could go through is one of these transactions. Um, you'll see a lot of this is just a fun tidbit. If you want to learn a bit about crypto, you'll see a lot of these transactions on HydraDX. The duck, you'll notice, and what this is called in crypto is a multi-swap batch all transaction. And as you can see in the kind of arguments that he's doing, what he's doing is he's swapping dot for stink and then stink back into dot, and he's making a tiny bit more dot on that. How that works is he's baking that all into one transaction. So we can see that unlike the sandwich attack, Mr. Duck only needs to submit one transaction. Pretty interesting, pretty cool thing. So yeah, you can use this code to review the HydraDX mempool. You can use this code to keep an eye on sandwich attackers. I think maybe if HydraDX wanted to, they could put this code up on another Discord channel, and you could kind of see the mempool coming out as well. As always, even when you stop this, like if we stop this code now, the attackers list is still going to be saved, so you can still go back and look at these attackers. One other thing is, if you want to run the code, I suggest running it with bun. Bun is pretty cool new JavaScript thing. You would just go bun HydraDX mempool san v2. As you can tell, I've been through a lot of instances of building this, but cool, that's how we would get it started. Now, I guess to summarize, I've been keeping an eye on this for the last few months. I've been working on this code for a few weeks, and I guess we probably want to go talk about like who's the worst sandwicher, who's the biggest fan of Subway and does the most sandwiches. Well, it's pretty obvious. We don't need a huge amount of sample size to figure that out. That it's this guy, and that this guy. I'll pull his wallet up now for everybody. This guy for now. Oh wait, that's not his account. I'll pull his account up now. So this is Subscan. Subscan is a bit like Etherscan, but for Polkadot. You can see all of the transactions this person has submitted. So he's submitted 2,870 transactions. Pretty cool. But as we can see, this guy is in the business of doing sandwich attacks. If you just want to kind of have a kind of rough idea of how he's doing this, or like if just on a first glance to tell, is this a sandwich attack? Let's look at two transactions that got confirmed. You know, they're both in the same block, so that's a bit of a tell. The first one, the asset in is 5. The second one, the asset out is 5, and he's obviously dealing in this transaction. And then if we went actually looked in through the code, we could see that probably in his first transaction he left a large tip. Yeah, we can do this. This is a bit confusing on. Yep, there we go. We can see in his first transaction he left a tip. So this guy Wex is in the business of doing these sandwich. WEX is in the business of doing these sandwich transactions. So if you are trying to buy stink coins or whatever, you need to be very careful. This guy is definitely watching the mempool. He is doing exactly what I'm showing you now in the code how to do, where he can see your transactions pending before they go confirmed. So there's a couple of seconds window where he can make a couple of quick decisions to either take advantage of you or trade at a better price or whatever he wants to do. So how these sandwich attacks work are basically the exact same as the code I've shown you. The only difference would be instead of, you know, determining is an attacker there, how we're doing it, he would just determine is there a potential victim. And then if potential victim, we just mirror the assets in, assets out, flip the second one, pay a big tip on the first transaction, pay a small tip on the second transaction, and boom, we're off to the races. I don't do any sandwich attack strategies myself. I don't see that as a super viable long-term kind of business model. I don't recommend doing them either. I think there's much better ways to make money in markets than preying on other market participants. But if you want to do it, I guess it's up to you. You best of luck, I guess. I don't think how tips work. Yeah, so that's I guess about it. Maybe the last and only final thing I'll tell you that maybe I might not have already kind of covered is these tips. Tips are really important. You can see this is Sunflower. I just know the address well enough. So like, let's compare these two transactions. So on this block, there were 2 transactions submitted. This one from Stink, or this one from Sunflower, and then this guy buying Stink coins. You can see that Mr. Sunflower has a tip, and this guy does not. So how the collators or validators will work is that they'll prioritize transactions with the highest tip because they obviously get that tip. That will basically enable them to just make a bit more revenue and have a kind of way of organizing each of these transactions. So it's as simple as, you know, if you want your transaction to get processed first, you will have to submit a tip with more coins than anyone else in that block, and then you get to go first. So I think that's about it. I just want to say thanks to the HydraDX Council and thank you to WAG Media. Without their support, I wouldn't be doing this. I will leave a link to the code below. You can check it out. I will be running this code myself for the foreseeable future, the next few months, years maybe. And I'll start to build up a big long list of attackers so we can kind of have a look through. Also, obviously, lastly, I wanted to say, you know, sandwich attacks don't just happen on HydraDX. This happens on every single chain, especially any chains with V2 liquidity. Even more so, like a lot of this is happening on Solana too. So I don't want to make it sound like that HydraDX are the only chain this is happening on. Just they seem to be the ones that care the most about the problem or educating people or helping people to get past the problem. So big kudos and respect to them. Very rarely do I meet DeFi teams that really care about this kind of stuff. So, you know, fair play to the HydraDX Council and the HydraDX community. If you guys have any questions or comments about the code, or if you want me to to work on something else, feel free to reach out. Only DeFi Guy on Twitter or the Oyster on Discord. You can see my Discord there, the Oyster. I'm always available to chat about JavaScript or whatever. So thanks for everything. The code will be commented below, and I hope you guys have a really great day.